Good morning, guys, or possibly good evening. We are going to be looking at the sum and differences of areas. Now, so far we've looked at the areas between a curve and the x-axis, a curve and the y-axis. So we could look at those sorts of things, but also we can possibly look at the area of between two different curves. So there's going to be lots of a variety of different types of questions. And obviously, I have said to you before, being able to sketch your graphs is an advantage, I guess. Well, here, it's not just an advantage, it's the most important thing that you can be doing. So we're going to start off with an example. Find the area between the curve y equals x squared and y equals x. Now, this is a fairly challenging question just to start with. But with any of these questions, as I said before, always start by sketching it. Okay, that's why being able to sketch curves is so important. So I'm just going to sketch the graph of y equals x squared as such, and then I'm going to sketch the graph of y is equal to x, something like this. Okay, it's important to exaggerate and make sure that they cut. So basically what we're being asked to do for this particular question is we're being asked to find the area between these two curves as such. So again, it's nice and important to be able to sketch that so you can actually see what you are trying to do and have the understanding about what you are trying to do. So how do we find the area between those two curves? Now, what are some things that we have done previously? Well, previously, we've been able to do this. We've been able to find the area between the graph y equals x squared and the x-axis. So, for example, we could find the whole area like that. We could also, if we wished, we've learnt how to find the area underneath a straight line, okay, which would be this area here in the x-axis. Okay, we would do those things by, well, the first one, we will find an integration between your boundaries b and a, or a and b, whichever you want to put it, and we would do the integration of x squared dx. Likewise, we could find b and a here and do the integral of y equals x dx. So how would being able to do those two things help you with this question? Well, this title of this lesson is Sum and Differences. So what that means is if I know what the whole area underneath the curve is going to be, y equals x squared, which basically means that whole bit underneath there, or actually we'll do y equals x, start off with that whole lot there, and then I take away the area underneath the curve, what's going to happen is I'm going to be left with that little bit of area between the line and the curve, as you can see there in red there. Okay, so that bit in here we'll be left with. So if I can find the area underneath the line and then take away the area underneath the curve, we're left with that little bit in green. So let's try to do that. Now, the only issue that we might have, I guess, is, we know what the integrals are going to be for x squared and for x. The problem is I don't know what my b and my a is going to be. Well, clearly you can see here that that point there is going to be 0 because that's the intercept between the x squared and the x at 0, 0. So what is that what that x coordinate going to be? Okay, that's the important part. Well, how do we find that? Hopefully you remember to find the points of intersection between two graphs, we can simply, let's say we're doing y equals x squared and y equals x, we can use simultaneous equations. Now, in this case, we can just put substitution. If y is equal to x, that means that x equals x squared. Rearrange it, x squared minus x equals 0. So now we're going to then factorize x outside of x minus 1 equals 0, which means x equals 0, which we've got there, or x is equal to positive 1, which means that value there is 1. Okay, so we're now going to put all that information in together to get our answers. So my area is equal to, now we need to do the integral of y equals x first of all, because that's going to be the bigger value. Hence why it's so important for that graph to have there. So we're going to look at the integral of between 1 and 0, y equals x dx. and then I'm going to take away the integral between 1 and 0 of y equals x squared dx. Okay, and now it's going to be a matter of integrating and then going from there. So let's integrate. We get x squared over 2, 1 and 0, subtract x cubed over 3, 1 and 0. We now want to go through our substitution. So we're going to have 1 squared is 1 over 2, subtract 0 squared divided by 2, 0, minus, and then my next one, 1 cubed is 1 over 3, minus 0 cubed is 0. So we're left with a half subtract 1/3, and then simply put that into your calculator to get your final answer. And you can either leave that as a fraction or as a decimal. I'm just going to leave it as a fraction. 1/6 units squared, and that is the area between my two curves. So look, it's a fairly complex process, I guess, but in saying that, there's nothing there that you haven't done before. All we're really doing is finding the area between the line y equals x, finding the area between the curve y equals x squared, obviously between the point 0 and 1, and then we're subtracting them. Okay, sometimes you might need to subtract, sometimes you might need to add. That's why your graph, your sketch is so important. Okay, let's have a look at another example here. You might want to give this a crack yourself, pause it, and then have a go, and then hopefully we'll walk you through it. Find the area enclosed between the curves y equals x squared and the curve y equals x minus 4 all squared and the x-axis. So this looks like to be two parabolas going on. So let's try to draw this, sketch this graph out to see what's sort of going on. Again, you need to make sure you do a nice diagram. If it doesn't really come out nicely the first time, then certainly you might need to draw it a couple of times. It's probably not the nicest of parabolas, but it is a parabola nonetheless. Y equals x squared. So the graph y equals x minus 4 all squared. Well, that means y equals x minus 4 times x minus 4. It's going to be a parabola, but what that means is the parabola is going to have a x coordinate of x equals 4, okay, which might mean it's going to be over here, which means that it will look like, ooh, that's a bit average. Let me just do that one again. Okay, so that's the graph of y equals x minus 4 all squared. So important that you be able to draw these effectively. So it says the area between the curve y equals x squared, y equals x minus 4 all squared, and the x-axis. So what that means is we're looking for the area underneath these two curves. Okay, so how do we do this? Because this is slightly different. Well, I guess what we can do, if we can find the area between this point and this point here for y equals x squared, okay, we can do that. That's something that we have done previously, okay, as long as I know what this coordinate is, of course. We're not on 0. But if I can find that by doing my integral, okay, of y equals x squared dx between those 2 points, b and a, whichever they're going to be. But then, if I find the area likewise underneath the second curve between those 2 points, obviously that's 4 and that's something else, then I might be able to add those two together, okay, to be able to find out what the total area is going to be. So this is in fact going to be what we call a sum question, okay? It's find the integration or the integral underneath those two curves and simply add them together. Now, like that last question we did, you know, we've got a coordinate here which we need. All right, that's a part that we do need. So how do we find that? Well, like last time, we're going to use simultaneous equations. We've got y equals x squared, and we've got y equals, well, x minus 4 all squared. Okay, what I might do, I might expand that out. X squared minus 8x plus 16. All right, and I'm going to let those two equal each other because they're both equal to y. So let's put those to equal each other. X squared equals x squared minus 8x plus 16. And now let's try to solve it. Let's get this x squared over here. So take x squared across. We're left with 0. X squared minus x squared is 0. So we're left with minus 8x plus 16 equals 0. Plus the 8x across. 8x equals 16. X is equal to 2. So I've got my value of 2. And that looks about right because it looks halfway between 0 and 4 anyway. But remember, you can't just assume, you need to show. Okay, so what does that mean then? All right, that means that I've got my boundaries. For that first one in orange, okay, we're looking between 0 and 2. So 2 at the top and 0. For the one in purple, okay, or pink, we're looking between 4 and 2. So I've got my two boundaries there. All right, and now just need to find the integral of those two questions and then simply add the areas. See, once again, how important is that graph? You know, being able to draw that graph is so important. Okay, so equals. Let's have a look at the first one. So we're going to have x cubed over 3 with the limitations of 2 and 0, or the intervals of 2 and 0. I'm going to be adding on, and now this one, now, we had up here, I did rewrite this before, remember I put this as x squared minus 8x plus 16. That's probably going to be easier to differentiate, so to integrate. You could use the chain rule if you wished. I mean, if I just integrate from here, it's probably easier. X cubed over 3 minus 8x squared over 2 plus 16x. However, I could have gone through and gone x minus 4 power of 3 over 3 times, and then if I do that, it's going to be times 1 and go from there. That will end up being the same question. Okay, it depends on what you would like to do. Would you like to do chain rule or that way? Okay, either way, this is what we're going to get up with the answer. Okay, 2 cubed is 8. 8 over 3 minus 0, because 0 divided by 3 is 0, plus, okay, so if I now substitute in, we've got 2 and 0 here, so 2 cubed is 8 over 3, minus 2 squared is 4, 8 fours are 32, 32 divided by 2 is 16, plus 16 times 32 is 32, and then for that one, if I do my subtraction part of it, it's going to be 0 anyway. So, okay, won't always happen, but most of the time it will happen. So, if I now chuck that into my calculator, okay, that's going to give me a nice answer of 5 and 1/3 units squared. Okay. But again, you could have, as I said before, if you didn't want to expand and integrate, you could have just done that method there, which may well have been easier anyway, but it doesn't really matter. It's the same answer either way. Okay, so again for that question, we drew the sketch of the two graphs. We recognized that we wanted to find the area between the two curves, so I found the area of one, found the area of the other, and I simply then added those two amounts together. Okay, it's not particularly easy, folks. All right, not particularly easy. The next one, find the area enclosed between the curve y equals x squared and the line y equals x plus 2. Okay, this is quite similar to the first example we looked at. All right, I'm going to sketch the graph y equals x squared, and then I'm going to sketch the graph y equals x plus 2, which means that it's going to be through that point there. And I'm going to, how are we going to do this? There we go. Okay. So x plus 2, I'll put my coordinate in here. That's going to be x equals 0, so y equals 0, so it's negative 2. Okay. All right. So it says find the area enclosed between the curves. Well, where's the area? It's between the curves. It's between these two parts here. Okay. Okay, so it's between those two parts there. It's not between this bit here. Okay, it's what's been enclosed. That's that word enclosed is very, very important. Okay, so how do I do that? Well, remember back to that first example, we said if we can find the area enclosed between these two coordinates, whatever that coordinate is there, okay, or those intervals, if I can find the area underneath the straight line, y equals, in this case, it's x plus 2 dx, then if I subtract the area underneath the curve y equals x squared, which is that part there, okay, and put those together, then I'm going to get my answers. Again, that happens because the area underneath the graph y equals x plus 2, which I'm just going to do here, would be this area in that blue color. If I then took away the area underneath the other curve, which is there in yellow, you can see I'd be left with that first one there, that area enclosed by the two lines. Okay, so how do we do that? Let's go through. We'll need to find B and A, don't we? So how we did that last time? Simultaneous equations. Y equals x squared, y equals x plus 2. Then we're going to substitute and make it x plus 2 equals x squared. Put it all to one side. X squared minus x minus 2 equals 0. Now, obviously, it's going to be a quadratic, so we're going to have two solutions. It's going to be x minus 2 and x plus 1 equals 0. So x equals 2 and x equals negative 1. Okay, so that's negative 1 and that's 2 there. All right, so I'm going to put up here 2 and negative 1, 2 and negative 1. See how it's all above the x-axis as well? There's no worries about having a positive and negative area, so there's no need to having to split things up even further than what we have to. So we can just do it in one hit. Okay, so let's go the first one. So we've got x plus 2. So we're going to have x squared over 2 plus 2x with 2 and negative 1. Subtract, and then I'm going to be doing x cubed over 3 and 2 and negative 1. And now it's a matter of substituting your values in there. These are obviously going to be, it's going to be a little bit longer because I'm going to have 2 and negative 1 there. Going to have two different values when I do this in total. So 2 squared is 4. 4 divided by 2 is 2. And then 2 times 2 is 4 minus, and then negative 1 squared is 1 plus negative 2. Okay, so that's my first one. And you can do this in two separate hits if you wish. And I'm going to be then subtracting. I'm just running out of room there. Oh, I might be able to get room on. No. I'll scroll that up a little bit. I'll be subtracting the right-hand side one now. So this one's going to be 2 cubed is 8 over 3 minus, and then negative 1 cubed is negative 1 over 3. And I need to put that in brackets. Ugh. If you do those two in two different calculations, it's probably a little bit easier. If I chuck that all in now, we should get 4.5 units squared. Okay, that should work out effectively. All right. Okie dokie. So what we're going to do now is go on to the final question. Example 4. Now this is certainly going to be different. Okay, I thought I'd throw this one in there because sometimes you see this word exact area. It is important to note everything that we're doing at the moment, like Simpson's rule, like the trapezoidal rule, this is an approximation for the area underneath the curve and between the x-axis, between the y-axis, or between two curves. It's an approximation. It is not exact. This makes this now a different type of question. I'm going to start the same way because I want to have a little bit of understanding behind what it's asking me to do. So I'm going to sketch this graph out. So it says, find the exact area enclosed between the curve y equals square root of 4 minus x squared and the line x minus y plus 2 equals 0. Well, hopefully you remember that this graph here, y equals root 4 minus x squared, is a semicircle. All right, it's a semicircle with a radius of 2, so that means that's negative 2, that's positive 2, and that's 2, and it's a positive root, so it's going to be a top part. Now, what happens if you forget how to do that, if it's a semicircle? Well, I don't like the square root, so what I actually do, I square everything, which makes it y squared equals 4 minus x squared, which makes it x squared plus y squared equals 4, which you know that to be a circle, but it's only the positive value of it, so it's the top half of the circle. So that's another way to think about it if you can't remember what type of graph that's going to be. Hopefully you do though. And the line x minus y plus 2 equals 0. So I'm just going to put the y to the right hand side and make it y equals x plus 2, which means I'm going to go through a y-intercept of 2. What's going to be the x-intercept? Well, when y equals 0, x is going to be equaling to negative 2. So it's actually going to be there. That's not bad. That's going to give us our 2 intercepts. Oh, it's hard to do that. It's just a bit narrow. Okay, so what it's asking me to do is to find the area between these two curves. So that tiny little bit of area between those two curves there, but it's exact area. Now, unfortunately, the minute it talks about exact area, that means that I am unable to go ahead and use integration. Okay, that's unfortunate. So how can I find the exact area between these two curves? Well, we have said that this part here is a circle. All right, this whole thing here is a circle, a semicircle. So what if I found the area underneath this area here, that quarter of a circle? How could I do that? Well, hopefully you might know that the area of a circle is pi times radius squared, where the radius in this case is 2 squared, and it's a quarter of a circle. So that's going to be, well, 2 squared is 4, 4 divided by 4 is 1, so the area is actually just pi of that quarter of a circle. If I then subtract the area of this shape here, which happens to be a triangle, then what's going to happen, I'm going to be left with the area between those two curves. So let's find the area of that triangle. Well, triangle is half times the base times the height. So half times 2 is 1, 1 times 2 is 2. So how do I find the exact area? Well, we then subtract it to get the area is equal to pi, subtract 2 units squared. Thought I might throw that one into you because I have seen that one a few times. It's a little bit different. So when you see exact area, there must be a separate way. Look, this has been a pretty complicated lesson. It's quite a long lesson too, so I do apologize, but I wanted to show you this because this is where your HSC questions will come from. Okay, they will certainly come from this section. They are quite challenging. I will do a lesson on exam questions at the end of this series, but please have a go at the questions. I think it's from exercise 3.8 from the Red Book. All right, that's on page 112. Go through and do all these questions. It is so important you complete them all. The most important part is to start sketching your graphs at the beginning of the question to give you greater understanding of what you are actually doing. Have a fantastic day, guys. Keep working hard.